So this is the follow-up on the last video where we were looking at hypothesis testing of two population means, and we answered question 18a. So before you watch this video, make sure you watch the first part and then come back to this video. So in 18a, we were testing a claim that the mean longevity for archbishops is less than the mean for the monarchs. And so the notations that we used in the hypothesis testing was we looked at our null hypothesis, which was that the population means were the same, so there is no difference. That means that there's no difference. And then our alternative hypothesis is from the original claim, which is this part right here, that the mean longevity for archbishops is less than monarchs, okay? And remember, archbishops, we call that population 1, so that was our P1, and the monarchs was our population 2, okay? So in our null hypothesis, we're saying that the claim is that the mean longevity for archbishops is less than the mean longevity for monarchs, okay? And then if you recall from the first video, this statement here, if we subtract mu sub 2 from both sides, then we get a difference of two population means, and that equals 0 on the right. So we mentioned in the last video that the difference here, so the difference is going to be a negative number. And the reason why it's going to be a negative number is because that difference is less than 0. And if you're less than 0, then that means that you're a negative number. Okay, so in this particular problem, though, we're going to focus on, we want to focus on constructing a confidence interval. So let's go back and recall what we did in chapter 7 when we were building confidence intervals. So recall that a confidence interval is a range. Oops. How do I undo this? Let me just erase it and bring out my pen, not my highlighter. Okay, so a confidence interval is a range, and that range in between it has our difference of our two means, okay? And you can write it like this, or you can, you can write it like this, or you can write it using the set notation like this, okay? And what we're going to do is we're going to go straight to our graphic calculator and have our graphing calculator build this confidence interval for us. So let me go back and read the question here. We want to construct a confidence interval that is suitable. Okay, so what we're going to do here is we are going to use on our calculator, so I'll use red here. Well, first let's say we're going to build our confidence interval. Okay, and so on our TI-84, we're going to use the 2, because we have two populations, sample T interval. And the reason why we're using T is because sigma is unknown. It is not given to us in this problem. Okay, now since our alternative hypothesis is that mu sub 1 is less than mu sub 2, this means we have a one-tail test, okay? And more specifically, it was a left tail. Okay, but the important thing is that it was a one tail. So when we drew that distribution, remember back in the first video, it was one tail. Now, whenever you're building a confidence interval, the right tail and the left tail have to be symmetrical, meaning in the hypothesis test, we were given alpha, an alpha level of 0.1. So when we build our confidence interval, these two areas, okay, they have to be equal. So that means that this area here is also 0.1. Now the reason why it's important for you to know if you have a one-tailed test or a two-tailed test is that anytime you have a one-tailed test, your alpha is always going to be times 2, okay? All right. Are we okay with that? Okay, so that means that if this is 0.1 and this is 0.1, so times 2, that's 0.20, then the region in here, this area here, this has to be 1 minus 0.2, which is 0.8. Okay, so this 0.8, this is your confidence level. So our confidence level is an 80% confidence level. So we're going to build our confidence interval at 80% level of confidence, or confidence level. Okay, so in the question, when it says construct a confidence interval that is suitable, this is going to be suitable because in our hypothesis testing, our alpha was 0.1. Okay, all right, so go ahead and take out your calculator and work along with me here. Do your 2-sample t interval, and when you do that, your calculator will give you negative 5.243 and negative 2.424, or if you want to use the set notation, that's, or interval notation, that's negative 5.243 comma negative 2.424. Now notice that these numbers that make up the lower bound, the upper bound, the confidence interval, they are both negative numbers. Okay, so does that confirm what we said in our alternative hypothesis, which we said supported the claim? Because remember, we rejected the null hypothesis from question 18a, okay? We rejected the null hypothesis from our hypothesis testing. So here, all right, we want to see if the confidence interval supports the conclusion that we made, which was to reject the null hypothesis. And hopefully you can see here that clearly the confidence interval does support our conclusion, because the confidence interval contains all negative numbers. And that makes sense because in our null hypothesis, if we subtract mu sub 2 from both sides, we can see that the difference of the two population means is a negative number. Okay, so that's how you build your confidence interval when you're doing a hypothesis test for the difference of two populations. Now in this particular problem, it just happens to be population mean that we were looking at, but the idea is exactly the same. The concept and the process is the same if you were looking at the difference of two population proportions. So I hope you find that helpful.